Okay, students, we are on notes 6.5 and 6.6, which is kites and trapezoids. This is your last set of notes for this unit, which means test will be coming soon. Okay, in your vocab folder, still page 23 at the bottom, you're going to need to write this down. Throw some color on here. So, definition of a trapezoid. A trapezoid is a quadrilateral. Now, notice it does not say parallelogram. So, we don't have those fabulous 5 properties of a parallelogram anymore. It is just a quadrilateral with only one pair of opposite sides parallel. Okay, so what happens in this shape is we do have our consecutive interior angles, and that's it. Okay, so there's not much we can do with this shape. But when we make this trapezoid isosceles by making the legs congruent, okay, so definitions will call those legs, or they will call them the non-parallel sides. So you do have to know both. But when the legs are congruent, we have other properties that show up, which we'll talk about in the notes. Okay, in a kite is also a quadrilateral with no parallel sides, but it has 2 pairs of consecutive sides congruent. So this is the only shape where it has these 2 congruent and these 2 congruent. All of our shapes have either had all 4 of them congruent or these 2 and these 2. This is the only shape that has consecutive sides congruent, so that's why it's part of the definition. All right, so we're going to cover kite first. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides, which are marked in my picture. If a quadrilateral is a kite, such as FGHJ, then it has the following properties. Okay, so one of the properties is the diagonals are perpendicular. So there are 3 shapes that have perpendicular diagonals, like that. 3 shapes with perpendicular diagonals. They are rhombus, square, and now kite. All right, so you might want to remember that because that can help you distinguish some things with some problems that we're going to have coming up. Okay, so we have Pythagorean theorem that can happen in here. When we have 90-degree angles, we have right triangles. So if I give you one angle inside that right triangle, you can find the other angle as well. Let me go ahead and say, because I have this picture right here, there is nothing up here that can help you get angles down here, because this kite cannot be folded over on itself this way. So there's nothing. This part of the kite is completely separate and unique from this part of the kite. Okay. Also notice these are isosceles triangles. Okay, isosceles triangles. So that means these angles are going to be equal to each other. But these angles are not bisected. Okay, so this would be a completely different number. So that's why I'm putting 2 dots. So these 2 angles will be equal. These 2 angles will be equal. In fact, the big angle here is congruent to the big angle here. Okay, but they are not bisected. And what happens in this shape, I'm just kind of telling you all sorts of things, is these angles are bisected because I can fold the kite over this way. If you will simply look at a picture and decide how you can fold it in half to get it to map on top of itself, then you will know what is congruent to what in the shape. So these angles, I'm going to put little marks like that, are congruent to each other. So if this angle was 20, each of these would be 10 and 10. And then these angles are congruent to each other as well. If this was 40, that would be 20 and 20. These angles are not equal to each other. You cannot fold a kite over that way to get this angle to map onto that one. Okay? This kind of takes care of what I was showing you in here. Exactly one pair of opposite angles is congruent. So this is the pair of angles that are congruent, not these. Okay? Another property that you're going to have in this picture that this doesn't talk about, I'm just going to write it over here, is 1 diagonal is bisected. Okay, so let's draw a picture. Best way to draw a kite is to draw a cross first. There you go. This is the diagonal that is bisected. Okay, and it looks like that. It looks like it's been cut in half. You can tell because this one is stretched longer that it is not bisected. Okay, I've jumped to this right here. So you might want to pause the video and just write this down. These are really the 6 properties of a kite, whereas the first one isn't really a property. It's just telling you that there's no parallel sides. This is telling you that these 2 sides are congruent, these 2 sides are congruent, 2 pair of consecutive sides congruent. The diagonals are perpendicular, which shows you that right here. The one diagonal is bisected. That's showing you in this picture here. This diagonal has been cut in half. 1 pair of angles are congruent. So that is showing you in this picture. These are the angles that are congruent. And then the last one, 2 pairs of angles are bisected. This pair and this pair. Well, it's not, no, sorry, I'm going to change that. 2 angles are bisected. You're going to find out that we like to say I'm going to write this way. 1 diagonal bisects 2 angles. Okay, so this diagonal is bisecting 1 angle here and 1 angle here. Sorry about that. All right, pause your video if you need to write that down. Okay, let's jump over here and do these problems. So I have gone in and I have written all of these into the picture. And this little marking here that I'm doing, whenever I'm given the big angle, I write the measure on the outside, but I darken the angle so that I know when I look at that picture, the 104 doesn't go with angle 2, but it goes with the whole thing. Okay, so I wanted to show you like angle, the answer to number 3 is going to be the whole angle because I have it darkened. Okay, so I'm going to zoom in a little bit so we can get closer to these problems, and I'm going to focus. There we go. Okay, so I have these in the picture. So the first thing I can do is I can find angle 1. I know that this is a right triangle. All 4 of these are right triangles. So these 2 angles are going to add to 90. So 50, 60, 70, 80, 90, 41 would be angle 1. So 41 degrees. You guys need to be writing these angle measures in the picture so I know you're actually doing the problems. Okay, and then if this big angle here is 104, I know that this big angle here is 104. And if I take 104 and subtract 41, that leaves me 63 degrees. So this angle is 63. So remember, these are congruent. So angle 2, the measure of or problem 2, is what? 63 degrees. Because 63 plus 41 is 104. Okay, so this one is 63. And then it wants the big angle down here. So I've got a right triangle. So 90 minus 63 gives me 27. So each of these are 27 degrees. And 27 times 2 gives us 54. If you will just remember how you can fold a kite in half, you can see the pieces that are congruent. Next question. Okay, again, write in here what I've got written in here. Number 4 is this angle here. These angles are not congruent. Be careful. Remember I told you, nothing over here will affect anything over here. Okay, so the way I get angle 4 is off of the 32. 90 minus 32 is 58. So angle 4 is 58, which means this angle over here is 58. We're going to need that because 5 is the big angle. So 4 is 58. I can go ahead and get 5 because I know if this is 64, this is 64. So 64 plus 58 gives us 122. So angle 8, or answer to 8 is what did I say, 122? No, I'm up here. Sorry. Answer number 5 is 122. Those two added together. And then number 6, I can use the 64. 90 minus 64 is going to be 26. So the measure of number 6 is 24. 26, excuse me. All right, third one. We've got 59 right here. 78 is representing the whole thing. So first thing I'm going to do is I'm going to divide 78 in half. And that means each of these are 39. Okay, so now I can get angle 7. 90 minus 39 gives me 51. So this angle is 51. And so that means the answer for 8 is going to be 51 plus 59, which is 110. No, 100, wait, 51 plus 59, 110. Let's double checking it. Okay, so this is 110 out here. And then number 9 is this whole angle here. So the way we're going to get that is I need to get this angle here. 90 minus 59 is 31. So if this angle is 31, this angle is 31. So this angle is 62. All right. Let's keep going. I think kites and trapezoids are the easiest shapes. Okay. A trapezoid. Oops, there we go. A trapezoid is a quadrilateral with exactly one pair of parallel sides. If the legs of a trapezoid are congruent, there we go. The trapezoid is an isosceles trapezoid. Okay, so looking at this picture, this would be an isosceles trapezoid. If the legs are congruent, the base angles would be congruent. If it were isosceles. So you guys know isosceles triangle. I'm going to show you the relationship. If I have an isosceles triangle with these sides congruent, that means these angles are congruent. If I draw a perfectly parallel line, what happens is it makes these base angles also congruent. So you have two bases, you have two base angles that are congruent, just like in an isosceles triangle, you had one pair of base angles. The base angles are on the parallel line, so they go left, right, left, right. These two angles are still supplementary because they're your consecutive interior angles. Okay, so these two angles here and here are going to add to 180 on both sides. Okay. In an isosceles trapezoid, each pair of base angles is congruent. If a trapezoid has one pair of congruent base angles, then it is isosceles. So if you have one pair of base angles congruent, it is going to be isosceles, just like the isosceles triangle theorem. A trapezoid is isosceles if and only if its diagonals are congruent. So if you have to have a problem where it says to prove that this is an isosceles trapezoid, you have to show the diagonals are congruent. Okay, let's jump into these problems. So we're reviewing with a kite problem. In this kite, angle BCD is the big angle, is 98. And angle ADE is 47. Okay, go ahead and find these three angle measures. If you want me to put numbers in here for you, I will. DAE, DAE number 10 is here. And BCE number 11 is here. And ABC number 12 is the big angle here. Okay, go ahead and find those three answers. Okay, there's your answers. I asked you this question here. Make sure you understand that. So first of all, I had to get this angle here by, these are going to be complementary. So I found the 43. I knew that because these angles are equal, this angle has to be 43. So then I got the 55 from subtracting 43 from 98. And then to get this angle is, I know these are complementary, so I found the 35. I knew these angles were this angle was bisected, so these are equal to each other. 35 plus 35 is 70. Okay, now let's go to the trapezoid. So all these questions are talking about isosceles. Guys, I'm going to tell you, the only thing you can do with a regular trapezoid, draw a picture. Make sure that it doesn't look isosceles. The only thing you can do with a regular trapezoid is these two angles are going to add to 180. That is it. So guess what the worksheets do not like to deal with? They don't like to deal with these problems because they're too simple. So a lot of the questions are going to deal with your isosceles trapezoids. But if it's just a regular trapezoid, you will be using that property. Okay. So question number 13, find the measure of angle J in this picture. So these angles right here are consecutive interiors, so they are supplementary. 180 minus 124 gives us 56. And then because this is isosceles, both of these angles are base angles, and they are 56 as well. So angle J equals 56 degrees. Number 14, in trapezoid EFGH, FH is 9. Find AG. Okay, so do you see this piece right here? This is 6.2. 6.2. The whole thing is 9. If I take 9 minus 6.2, it leaves me, this little piece is 2.8. So basically, they're just making sure you know that FH is 9. EG is also 9, so we subtract, and AG equals 2.8. Number 15, find each value so that the trapezoid is isosceles. To make this trapezoid isosceles, the base angles would have to be equal. So we have got 5x squared plus 32 equals 7x squared. Subtract 5x squared. Divide by 2, and we are going to take the square root. Okay, so we get x equals plus or minus 4. Please pay attention, you do have two answers. We need to verify both answers work. So if I take a 4 and plug it into this, well, I know the positive is going to work, but we got to check the negative to see if we get the same answer on both sides. What's going to happen is when you have a negative squared, it changes to a positive, so we're going to get the same answer for both of them. So I know they're both going to work. So x equals plus or minus 4. To go over that again, because the x is being squared, then it doesn't matter whether I put a positive 4 or a negative 4 into the problem. Okay. Number 16, find the value of z. This is talking about AC and BD. These are the easiest problems in the world. So it's going to be 2z, and then add 3. Z equals 6. Moving on. Okay. Trapezoids also have one more property, and it is called a trapezoid mid-segment. The mid-segment, some books will call this midline. Okay, the mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. I am not sure if that's in your vocab folder or not. Okay, I found mid-segment of a triangle. I want you to look. A mid-segment, no matter what, has to connect the midpoint of two sides of a triangle or two sides of a trapezoid. So if I cut off the top and we have a trapezoid, I can have a mid segment right here as well. Okay. When I have a mid segment of a triangle, it has properties, and the properties are over here. These two sides are parallel, and then this length is half of this length. Okay. When I have a mid segment of a trapezoid, the properties are just a little bit different. Okay. So we skip this. I'm going to go ahead and highlight it. And I might give you maybe an independent practice worksheet on this because it's not hard at all. But go ahead and know that I kind of talked about mid-segment a little bit in your vocab folder. Okay, but anyways, your mid-segment is on here very clearly. The mid-segment is the midpoint of two sides of a trapezoid. Okay. It has certain properties. First of all of these lines are going to be parallel. So we have corresponding angles. We have consecutive interior angles here and here. We also have consecutive interior angles here and here. Okay, so I'm going to put consecutive interior angles, and then we have our corresponding angles. Okay, and then the length of the mid segment. Okay, the length of the mid segment, I don't know exactly what they want me to put there. I'm going to just direct you straight to the formula. So the mid segment AB is equal to half of the sum of these these two segments. Okay, so I don't like formulas that have half in them. I'm going to give you a different formula. Okay, so I'm going to say 2 times AB equals MN, equals MN plus LP. I like that formula a whole lot better, and you're going to see me do this a lot, and you're going to get used to it, that we need 2 of this to equal the sum of these two segments here and here. Okay, so you're going to get a lot of practice of this. First of all, when you have problems like this, put an X wherever the missing value is. Okay, and that'll help you with the problem. So this is what I need 2 of. So we're going to make an algebra problem every single time. 2 times the mid segment equals base plus base. 16 plus 26, 42, and then x equals 21, and that is the answer for KL. KL equals 21. Okay, so which one do I need 2 of? I need 2 of this one. So we're going to say 2 times 7.5 equals base plus base. So what is that, 15? And we get 9.5 as our answer. PQ equals 9.5. Now, for this problem, let's go with one that doesn't have the decimals. I want to show you what's going on. If you think of going up the steps, like going up the steps to a building in Nashville, okay, the mid segment is actually in the middle of these two numbers. It's an average. So the number of steps it takes to get from here to here is the same as to get from here to here. Watch. I'm going to count on my fingers so you can watch. Okay, so we're going to 21, 16, 17, 18, 19, 20, 21. That's 5 steps. So then from 21 to 26, 21, 22, 23, 24, 25, 26. It's the same. Okay, so that's what's happening with the mid segment. So go ahead and you find the answer to number 19. Okay, number 21. Now I think this actual problem shows up on your homework. It may have different numbers in it, but it's the same concept. And this is something I haven't covered yet. Notice there's no diagonals. We just have angle measures, and we're trying to get from a kite into a trapezoid. And the way we're going to get in there is these two angles are equal. So in a kite, you have to know which way you can fold it in half. I can fold this down over here. So this angle is actually 137. what you need to remember is how many degrees are in a four-sided figure. That's how we're going to get x. So remember, n minus 2 times 180. So 4 minus 2 is 2. 2 times 180 is 360. So remember, this shape has 360 degrees in it. So we take 360 and we subtract 137, and we subtract 137, and we subtract 22, and that leaves us 64 degrees. Okay, then to get into the trapezoid, this is an isosceles trapezoid. Regardless of whether it's isosceles or not, these two angles, because these are the parallel sides, these two angles are going to be supplementary. So this angle is 43 degrees. Just to finish it out, this would be 43. This would be 137. Okay. And we've already done enough like number 22. We're going to move on. Okay, so I'm just going to jump around. I want to do this one. So number 12, I'm going to ask you, what do we need 2 of? This. Remember, if it's a mid-segment, we have to use 2 times the middle. So 2 times 2x minus 1 equals base plus base. Go ahead and get that answer for me. There's your answer. So I think we've done enough of these. You would need 2 times this to equal base plus base. You would need 2 times this to equal base plus base. Not going to do any more of those. So this one here, first of all, to get x, I know that 2x equals 111. Okay. Because those are the angles that are equal. And that would be 55.5. Okay, x is going to be equal to 55.5. All right, back up here to the kite. So just to show you that you can use the Pythagorean theorem, pay attention. If it says radical form, give radical form. I'm not sure what the worksheet says, so you just do whatever the instructions tell you. If I, let's just find a side length here. So if I'm going to find the Pythagorean theorem, let's say I want to find x right here. Your right angle is here, so we would say 5 squared plus 12 squared equals c squared. And we do get c equals 13. We would get a radical for this one. Let's go ahead and do that work. This would be 5 squared plus 5 squared. And we are going to take the square root of both sides. And 50 is 25 times 2. So the square root of 25 is 5. Radical 2 stays in. So my answer would be 5 radical 2. If you're wondering why I'm not putting the plus or minus on these, is because the length has to be positive. Okay, back on the other one, when we were solving for x and we were going to substitute back in, you had to check both answers. But for the Pythagorean theorem, it's always just the positive answer. Okay, so I just want to make sure you know that you can do Pythagorean theorem with those problems. And then this one here, I want to go over because sometimes these are the easiest questions there are, but sometimes students have trouble with them. So you've got to remember which angles are equal to each other. In this one, this angle is 88, and then I think you know how to get that. You take 360, subtract 88 twice, and then subtract the 120, and this angle would be 64. Okay, so this one here, we are going to remember that these angles are equal. So it's kind of like what we did in the isosceles triangle, where you're going to subtract from 360 and then you're going to cut it in half. So would you please tell me what the measure of angle M is going to be? All right, so we take 360, subtract the 60, subtract the 50. Whatever's left has to be split between these two angles, and so it gives you 125. And then the only thing left are things we've already covered. So I think we're done with the notes right at 30 minutes. Thank you, students.